Hello everyone, welcome to Engineering Mathematics. This is the second class for this uh, week second. Actually, we started this class the last week due to the coronavirus. It has been postponed for 2 weeks, so we are facing the end of the March already. So outside you can see so many uh, blossoms already. So feel free to be relaxed and focusing on engineering mathematics too. So from today, actually, we are starting from the previous lectures, like uh, engineering mathematics. Uh, but at the time, I have focused on what is the important things for our advanced engineering mathematics. So at the time, I emphasized how we can learn something, even in the mathematics too. We must recollect our human beings' learning process. Human beings are also very adaptive to learn so many things, as you know. So we must be familiar with some expressions and some terms. So terms will have specific terms words, as keywords sometimes, and that is being expressed in some uh, stereotypes of uh, forms. For example, sentence or words, or sometimes it can be expressed in an equation, especially as the functions of in mathematical form. And also, you must put some items or terms as in words or terms, so that could be not kept noted on your book, so you are going to be familiar. So actually, human beings are very familiar with the learning process, but how we can feel ourselves, how we must learn, and how much we can learn. So if you recollect our process of learning, then it is so uh, insightful for your learning process, so you can learn more. So I recommend you can keep on and pay much more attention on terms and how to express those terms in sentence words or sometimes in mathematics, especially in equations form. So those things will be kept on your glossary. So each term or equations will have such a definition as a minimal or formal expressions to describe that, and also it has the meaning. So you must understand what is the meaning of that expressions or words, or sometimes that is equation. In the meaning, you may understand about the physical sense or logical sense, how you can easily understand that to persuade yourself. So this morning, we are going to talk about the exponential functions. It's in the form of the, as I have shown this here, in the form of this kind of equations. So as you see in the previous week, actually we have focused on this. This is one type of equation. So when you see this type of equation, we think first this is called as a first order differential equation. First order means the derivative order is the highest order of that derivative in each term. So this is maximally 1. If there is no 2 primes, so only 1, so we call first order. First order differential equation. Differential equations means equation is something in the form of the equality I said at the time, y equals to f of t. In this case, this is one type of equation because that has been used equality on this equality, So we call that equation. So the maximal order of the differential equation, derivative, that is the first, so first order and differential equation. Differential equation. differential means, you have already learned, for example, this type of equation, y equal to ft. If that has a y1 prime is defined as in the form of df, here y, or dt. So dy means y t plus dt minus y t divided by dt. So eventually dy means here, this part we call numerator or nominator. So this is according to this variables variations, the value itself, how much different from the distance in the interval of the t. So if you write down, this is well known. So for example, if there is a t here, a certain t here, if there is a value that is we call yt. So if there is some dt here, increment on t axis, then the value is going to be yt plus dt. So yt plus dt minus dyt means this minus this. That means this part. So dt is this already. So we see this is the dt. So that divided by this. That is the derivative of this y prime. So we call this as a differential. So differential means sometimes differential is caused as difference. So that is the difference between in a certain values, how it differs with each other. So that is the meaning of that differential. It's in the form of that as a definition or equality. So if you already know this, then what does this mean? So if you see this, so if you see this, first ordered differential is equals to original one. That means what is that? So we must understand that as a definition or meaning, in the form of that. So in the case of one certain amount functions such as things again, if I write again, if t equals to 0 here, there is some value here. So if that is 1, for example, then what is the differential? What I said, that is the first order differential is something like this. In the case of t equals to 0, the value is t, y equal 1 when 0, right? T equals to 0, the y equals to 1 here. Now y1 prime at 0, that is this. If that is same lower part and the higher part, width and the height is the same value, then that is 1 divided by 1, that is 1, right? So we call that y0 and y1 prime is the same here. So as in this case, if the value t is going to be bigger here, for example here, then there is some values here. If that is, for example, 2.7, for example, then the differentials, we call that gradient. That is also something like this is 1 and that is 2.7, for example. Then in this t, that is the value is 2.7 and the increment is 2.7. That means y sum t equals y1 prime sum t value. This is the meaning of that. So in that fashion, we can draw that again. We can draw this, in this case, like the form of this. So we can draw in this fashion. If that is going to be bigger t is going to be bigger t, then the the gradient is also going to be very, very big according to its value. According to its value, this is the value at t here. The gradient, this divided by this, that gradient is also very, very big, so that is the same, the value of this. We call that is the function of this, y prime equals to y. That is the meaning of this. So after all, if you have such a equations, then how we can derive this, what type of yt is that? That is the solution of this kind of equations of this. So here, then it is very big questions or good questions how we can derive this type of equations of yt. So can you make it? All right. So this is one big task. Task 1. We can derive. We should, you or we should derive what is yt. So if you, as a first task, we are going to do this. So I like to say, so for example, if you suppose yt equals to something of equations like at, then if you suppose yt equals to at, then we want to check it out. What is the a? T is just a variable. We call t is a variable. Variable means, as we have seen this before, this type of value, we call that as a variable, because on this axis, t value is going to be changes like this wherever. Usually when we see that the t is in a certain real number. This is one type of writing in mathematical form. So anyhow, when you want to derive this type of yt, how we can check it out, function of yt. So from the definitions of differentials, so y prime t, that was, what was that? dy divided by dt. That dy means yt plus dt minus yt divided by dt. So we know this, this part is a, in the case of this y. If p supposed yt equals at, then at plus dt minus at divided by dt. So we can make a contract form at, because that is common, a dt minus 1 divided by dt. That is y1 prime t. So if it says, suppose this is the same form of this equation, y1 prime equals to y1 prime equals to y. If you suppose in this one, then we'll say that is at. So from this, because I said y1 prime equals to y. So from this, how we can check it out again, because this is equality here. So both sides has the at, so we can erase this at. So a dt minus 1 equals to dt. So as to the definitions of y1 prime t, that is there is a missing here, but there is a limitations of dt goes to 0. So actually dt goes to 0. So if I say that dt goes to 0, limitation, so we call just dt simply d. If you say so, then a d equals to d plus 1. So a equals d plus 1 d square root. So as we supposed here, dt goes to infinitesimally, infinitely small, very, very small, So if you suppose that we want to check out this a, what is this a? So if you suppose that a goes to here, if d equals to 1, then a is going to be 1 plus 1 divided by 1 divided by 1, that is 2. But actually, this d is not 1, because as we have mentioned here before, d goes to smaller, equal to 0. So if you suppose that smaller than that, then we are going to suppose d is 1/2. Then a is going to half plus 1 second square. So that means, this means, 1 divided by 1 divided by half. So that means 3 divided by 2 squared. Then that is 224, and this is a 339. So that means 2.25. So actually, in this way, we can make it much more simpler way. 1/4, for example, then what is 8? So that is 4, 5, and 4. Then that means 4 times 4 times 4 times 4 times 5 times 5 times 5 times 5 times. So then that is a 25, 625 divided by 16, 256. Now this is a very a shortcut, but this is a very common numbers, 25 squared and 16 squared. Yeah. So the value itself, it is not calculated all the time by your simple code it on your brain, but you can use that. So how? We can use that calculator. So you can check out this. You can use that. So simply, So if it says this, for example, whatever that is getting smaller and smaller. So for example, 1/16, then what is 8 at? So for example, we skipped the 1/8, but anyway, we can check that. So you can make it by this one. What is that? 16, 17, those 16 times, right? That means, you can compute this. You can use some Excel files or some other computer calculator on your system. So for example, 17 times, not this page, not this one, 17. 17 times 16 equals to 17 to 16 will give you, oh my gosh, so divide by this number, divide by quite a big number. Memory, and 16 divided by 16 to 16 equals to 2.63 789, and so on. Yeah, of course, this is infinitesimal decimal numbers, but we can check it out. So we can find this is going to be much more smaller and smaller. Then the value a is going to be, for example, big N, n plus 1, n times. That goes the number as a single numbers that point 2.71716 and so on. The value is something like that. So that is called one single number. So we call that as the name of the specific number, like specific scalar number, something like this. So if you can search out through this type of exponential notation, here is exponential notation. Sorry, not this one. Sorry. Exponential number. Here we call Euler number. Here number E, exponential, or we call exponential number or Euler's number. So that is number 2.71828, something like that. That has been often called Euler's number after Leonard Euler's. So we call that this Euler number was as an exponent basis. We call that. So this is called something like this number called as Euler number. So eventually, what was this meaning? This meaning was when you follow with this type of equation that A is going to be E, so that is ET eventually. So that is the meaning of y1 prime t2. Yt is going to be y1 prime t. So in other words, y1 prime t equals to yt. In that case, that is at, that a is e, so et. So this is exponential function. We call this as an exponential function. So at that time, we use that Euler number E, Euler number as a basis for the exponential function. So this has been our first task. What was the task? How we can derive yt is going to be y1 prime t. From that, y1 prime equals y. So from that, we could get yt as an et. So you understand this? So how we could generate exponential functions from that kind of derivation. So this is one important way how to derive the exponential function. So that was the simple first order linear differential equations. Y equals y1 prime t. So in the case of y is et. In other words, with this type of equation, what is the y? That is the how to solve that yt is called yt equal, that is et. We found that. So second way we can derive how we can generate that things, another task 2, I mean, y prime t, y prime equal y. In that case, how we can generate that y from what here, how we can generate that. Yes, we have another, we have got a first task, how we could generate that, the y equals et. But here, if we suppose y as the functions of one type of infinite polynomial, a0 plus a1t plus a2 t2 t squared t2 2 and a3 t2 3 and a4 t2 fourth. So with this type of things of an t to n, these fashions of equations. So we often call that is as a function summation of n goes to 0 to infinity. We can write in this fashion. So anyway, if you suppose this y equals to infinitesimally expanded as a extension of polynomials, then we can regenerate that y1 prime. So here, y1 prime is going to generate it from here. This is constant. So constants, if you make a differentiation, then that is a 0, right? So if you make this one, then that is going to be a1 and t is a t to 1, right? t to 1 minus 1 is t0. That is 1. So that is, t to 0 is 1, right? So in this case here, if you differentiate this, then 2a2 and t1, t2 minus 1 is 1. So the same way, 3a3 t3 minus 2, 1 is 2, right? And this one, 4, same way, a4 t2 3 and forever. So from these two equations, if we have these conditions, 1 prime is going to be this original one, then that is this and this is same. In other words, the right hand side is this one. So from this comparison, we can see this, we can see that comparisons. So zeroth order base is, zeroth order means t to 0, zeroth order is a0. a0 is going to be a1. So a1 is going to be a0. Here, t to 1 first base, that is here, right? The same one here. So 2a2 is going to be, so 2a2 is going to be a1. That means half a1. That means half a0. So if you say that a0 is 1, if you suppose, then that is 1 half. So the same way, similarly, same way, we can generate t2 to 2 is the same. So a3 is going to be one third times a2. So from that, a2 was 3 times this one, 2, 1, 2. That means 3 factorial, 1 over 3 factorial. Same way, a4 is the same one, 1/4 a3, because a3 is going to be 4 a4. So a4 is a3 divided by 4. That means 4 divided by this part, 3 factorial. That means 4 factorial. 1 over 4 factorial, right? So in this fashion, so an goes, an nth coefficient, nth order coefficient an is 1 over n factorial. So eventually we can rewrite here, we can rewrite this equation. Y goes, that was here, n goes to 0 to infinitely, expanded as a polynomial, and ordered 1, t n. If I see that here, 1, 1, half, 1 divided by 3 factorial, 1 divided by 4 factorial. So that is one coefficient part is this, and nth order basis. So this is the 1 plus 1 t plus second t squared, 1 third factorial, 3 factorial, t to third, and 1 fourth factorial, and t fourth, t to fourth, and eternal. So this is the function of that. Then what is this meaning? So from those result from the two tests, we have derived. So we can find y1 prime equals y. If you say that y is going to be what? Et. That what is that? That is this 1 over n factorial and tn. So this is the a real result what you have derived from that equations. So we have spent half an hour. So how to derive this kind of function, which is y equals to y1 prime. So what is the meaning of that? That is a first order equations of the ordinary linear equation. So from that we could generate it. Y1 prime equals to y. If you say so, then that y is, at that time, that is et, that is summation n to 0 to infinity 1 over n factorial tn to n. So this is our resolutions, how we could derive this type of first order differential equation and its solution y t equals to et. The value is eternally described in the multi-polynomial equations. Multi-polynomial equations means 1 plus t plus f t squared plus 1 to factorial divided by factorial t to the third, and then eternally they will repeat. So from this, we can get on conclusions. So from those two approaches, they are eventually the same. So exponential functions could be generated in the sum of the polynomials in form, and that was et too, with an Euler formula, Euler numbers basis. I mean, this is basis, and this is that equations variable. Yeah, actually, even in the mathematics, when you learn the mathematics, there is so many terms. We call this as basis or base in the exponential, and this is here variable. So in some polynomials case, for example, in the second order equations like y equal a t plus b, for example, t is a variable because y is yt, right? So at the time, this is called as a variable, and this is called as constant number, and this is called as a coefficient. So these are all has its own meaning. So what is this y? That is called as a function or the value of that function. So function or value of that function. All right, this is the short summary. Now, what you have learned now, we must summarize when you learned what you have learned. Okay, and why we summarize, that should be summarized to be explained to somebody else. That means that is evidence that you know that concepts or the derivation. And of course, you must do some exercises with examples in the textbook. And and you can devise any item on the scope of the category, so you can understand how can you must expand your knowledge. So if you have any questions or things, then you must do some questions as according to your curiosity. Thank you very much.